get to see the rest of them tomorrow. So your kids are in good hands. So we're going to frame our conversation today around 5 myths about math. And I will preface all of this by saying I don't really believe that you believe any of these things, but I want you to just, when I present a myth, I want you to think about, did I ever believe that, or is there some of that that I think rings a little bit true to me? And then what Singapore has to say about it. So I think you guys know this, that Math in Focus is based on the curriculum that is being used by about 90% of students in Singapore today. So it's page for page the same mathematics as what kids in Singapore are using. The teachers' materials are kind of enhanced for an American population. Why Singapore? Why are we?
That's a good question.
Yeah, I love it. Aren't you glad I asked? Why Singapore?
They focus on education.
Oh my gosh, that is so true, and it is fascinating. In one generation, so if you take Singapore, the Singapore people that would be our peers, some of us are different ages than others. I'm not going to point out who that might be, but I know, exactly. Some people are a little bit younger than I am. But if we think about, oh my gosh, okay, we're just not even going to do the math there. So if you think about in one generation, people that would be my generation in Singapore, the Singapore of today is high achieving. They're top of the world in a lot of things. In a country that doesn't have, really they don't have a lot of natural resources. They don't have really almost any natural resources. If you go back one generation, this Singapore is a very different place. Poverty stricken, really just terms of, like many people in that generation didn't even have a high school education. So in one generation, they have completely turned this country around. It's not because they invested in any sort of natural resource or certain industry. It's because they invested in education. And they would tell you that. I mean, it's really all over what you, documentation about the growth and development of that country. That they went from being a developing country to a first world nation by investing in their children. So what else? Why else are we looking at Singapore?
Probably a concentration of high tech there. Or...
Yeah, when we compare where they are in terms of industry and just competing globally, there's one other reason that people in education are looking at Singapore, and that is for over 20 years, Singapore has been at the top of the world in terms of math and science assessment. Now, of course, that's just one tiny little piece, but it's really interesting. If you compare Singapore students to American students, they tend to be the same in 2 areas. So if it's just straightforward computation, you know, can you add, subtract, multiply, divide? American kids are right there with Singapore kids. If you compare, so I'm going to say like 1 or 2 step problem solving situations, can I put you in a problem solving situation that requires a couple of steps mathematically? American kids do that really well. Singapore kids do that really well. The area where they are drastically different than US students is their ability to take something that they know mathematically and apply it in an unfamiliar situation. Take content knowledge and apply it to a novel situation. Can American kids do that? Heck yeah, American kids can do that, absolutely. Why is it that they don't do that as readily? Because we haven't asked them to do that very often. That was not part of our experience, for most of us, when we were in school, that nobody said to us, can you take what you know and apply this to a situation that looks new and unique? So that's one of the things that this curriculum is going to do for your child. Okay, so there's a couple of good reasons that we're looking to Singapore, but this is not a evening about us becoming Singapore, because that's not the goal. The goal is that our kids have the same opportunities that children in this country do. Oh my gosh, what just happened here? All right. Time down. Okay, myth number 1. The math my child is learning is new and different from the math I learned. What do you think? I hear a no. Does anybody say yeah?
It does look different.
I love it.
The layout is different.
You guys are so smart. Okay, so here is the truth. It's the same math that you learned. There's just a different focus. So I'm going to give you a couple of examples of this. Can you hear your 2nd grade teacher's voice in your head when you solve this problem? So what's that teacher voice saying to you?
What is 120?
Okay, 182 plus 93, she might be saying that. Anybody hearing anything different?
2 plus 3.
2 plus 3 is 5. What's she going to say here? 8 plus 9 is 17. Carry the 1. Thank you very much. Okay, that's what our second grade teacher taught us. There's nothing wrong with that, right? But that is a memorized procedure. Carry the 1? What is carry the 1? So your students are going to be learning this mathematics, but they're going to start first by building an understanding of what that math means. So this is a picture of what it would look like in the textbook, but kids aren't learning this math by looking at a picture in the textbook. In the second grade class that I was in today, we were doing the same sort of math, but we were subtracting. So they're building this, all right? So now all of a sudden the language becomes 2 1s plus 3 1s are 5 1s. 8 10s plus 9 10s are 17 10s. And then that whole, what we say, carry the 1, for a child has some mathematical understanding, right? I've got these 10 10s. I know that another name for 10 10s is 100. So it's the same math, right? Just understanding built in before. The writers of this curriculum value 2 things, and they value these 2 things equally. One of those things is conceptual understanding. That's this. The other is procedural efficiency. Okay? Our teachers really focused on procedural efficiency, but often skipped this conceptual understanding piece. So I'm going to back up. So one of the things, so focus on place value, also a focus on understanding. So one of the things that your students are going to be asked to do from time to time this year is to think about solving a question in more than one way. Because if I ask kids to just solve this, many of them are just going to crank through the procedure, right? If I ask them to solve it in more than one way, what's that going to show me?
Their understanding of the concept.
Yeah, that they understand it enough that they can do this. So I answered this question in a classroom of second graders recently, and they're just like your students, that they're brand new to math and focus. Okay, so 182 plus 93, and I said, can you solve it in more than one way? So everybody immediately solved it in the way that you and I would solve it. And then a group said this. We're going to start with 202 instead of 182, and then add 73. Why did they do that? Exactly. You don't have to do that whole regrouping thing. What do you know about a group of second graders that can solve this question in this way? What do you know about them? Yeah, they understand the numbers. They have operational sense, right? They know, well, it's easier to build 202 than 182. I won't have to do that whole regrouping thing. And if I make this 20 bigger, I have to make this 20 smaller. Okay? Same mathematics that you and I learned, different focus. Strong focus on number sense, the ability to be a flexible thinker. We want students to understand and be efficient. Okay? I'm going to give you another example. This is a 4th grade example. What's going on with our farmer friend? He's dividing some lettuce, right? I answered this question with a group of 4th graders recently, and a little boy in the classroom said, heads of lettuce. What's a head of lettuce? And I was kind of horrified. I was like, he's only ever seen lettuce in a bag, or something like that, right? So anyway, farmer has 525 heads of lettuce. He's dividing it between 3 restaurants. If I asked you to solve this, can you picture what you would write down on your paper? I bet you can. So most of you would write something that looks like this. True? Okay. So your child is going to learn this also, but not void of understanding. Do you remember how your probably 4th grade teacher or 5th grade teacher taught you long division?
How many 3's go into 5?
How many 3's go into 5?
What's the remainder?
Bring down the, yeah, right, bring, whatever, there was something about bringing down, good, okay. Yeah, teachers do crazy things things to get kids to remember this procedure. Why is long division such a difficult procedure?
The remainders, maybe.
Okay, good. I have to think about what those numbers mean. Anything else that makes it difficult? It is one of the most challenging algorithms for a child to learn. There's so many steps to the process. What did you say? Okay, good. So not only are there so many steps, but they're involved. I've got to know how to multiply. I've got to know something about division, right? Have some sense with that. I've got to subtract. I've got to know how and when I do each of those things. Any other reasons it's so challenging? Lots of steps. Gosh, I've got to think about number sense and organizing all of this information. So teachers do crazy things to get kids to memorize this algorithm. They teach them a mnemonic device, like, do monkeys smell that? You know, divide, multiply, subtract, bring down. I know, it's crazy, isn't it? I learned recently in the state of Kentucky the long division dance. Did you know there was a long division dance? I had no idea. I was just going to say I will not be performing it for you this evening. What is wrong with like a mnemonic device or the long division dance? Because teachers are doing those with good intentions. What's the problem?
It's a bunch of steps.
It's a bunch of steps, and what happens if I forget a dance move, or I forget, what does the M stand for? The M, monkeys. What math is that? All of a sudden, I can't divide, right? The writers of this curriculum want a child to remember this procedure because they understand the mathematics behind it. So we're going to look at this. I'm going to be showing this to you virtually for obvious reasons, but if you were a 4th grader in this class, you would be building this. You'd have a place value mat like this, and you'd have these they call them place value chips, kind of like poker chips, different color, different value, right? It's not really about the chip, it's about where it lies on the place value mat. So you can see the connection between this and the 2nd grade question that we looked at earlier. Where shall we begin?
The hundreds.
Ooh, the ones or the hundreds. I don't know, I heard both. Here's the interesting thing. On a place value mat, I can begin either place. It's just messier one way than the other. So kids that have solved this question on a place value mat are going to remember to start in the hundreds, not because their teacher said, boys and girls, when you divide, you always start in the hundreds. Did you know that this is the only algorithm where we start with the largest place value? Everything else, we start with the ones. When we add, we start with the ones. When we subtract, we start with the ones. When we multiply, we start with the ones. When we divide, we start with the largest place value. It's one of the other reasons it makes it challenging. So kids are going to remember that not because their teacher said, boys and girls, the rules have changed. They're going to remember it because they tried it the other way, and they just realized it was less efficient, messier. So we're going to start in the hundreds. I'm going to keep track. So kids would be answering this first on a place value mat, and then ultimately record keeping here. I'm going to do both at the same time, okay? So you guys can see the connection. We're going to start with the hundreds. How many hundreds can each restaurant get? Do you see our 3 restaurants, by the way? You see our 3 restaurants?
Yep.
Okay. Yes, and you see the 525 heads of lettuce. And you just said each restaurant is going to get 100. Okay, good. Okay, each restaurant gets 100. I have 2 left over. Let's keep track of that here. Each restaurant received 100. How do I know that's 100, by the way?
It's in the place.
Yeah, it's in the hundreds place. So 3 groups of 100. How many heads of lettuce have I just distributed? 3 or 300?
300.
Yeah, 300. There you go. How many heads of lettuce are left? Do you see them? Do you see them? 200. I have 2 hundreds left. I have 2 tens. I have 5 ones. Right? What shall we do with these 2 hundreds? Ooh, that's such a great idea. Usually somebody will be like, cut them up or whatever. She said, there's another way to build hundreds. Let's build them with tens. 2 hundreds would give us how many tens? 20. So how many tens do I have altogether?
22.
I have 22 tens. Do you see that here? So a child in Math and Focus, I just got done talking to the teachers about this. A child in Math and Focus spends a lot of time developing a sense of number, right? So that they can say things like this. I know that another way to build 220 is with 22 tens. I want you to imagine with me for just a moment that there is a child in our 4th grade class who doesn't know that 3 times 7 is 21. Is that possible?
Okay.
Yeah, there's probably probably 2 of them, or maybe even 3 of them in that class. It's really common. That's another challenging thing about long division, is that kids that don't have fact fluency, they are investing so much cognitive energy in like 3 times what is 22, that they really have a hard time investing enough in figuring out what the goal is, and the goal is long division. So what is that child going to do on their place value map? A child who doesn't know that 3 times 7 is 21. What are they going to do? It's exactly what they're going to do. They're going to deal them out. This doesn't keep a child from learning their facts. It really strengthens an understanding of their facts. So a child that the first time says 1, 1, 1, 1, 1, 1, is guaranteed not going to do that the second time. The second time they're going to go, wow, that took me forever. I know there's at least enough to put 5 in each group. And I'm going to go from there. Really moves them towards more in-depth understanding of their facts. We know that 3 times 7 is 21. So how many 10s is each restaurant going to get?
7.
Yeah, each restaurant's going to get 7 10s. With this 1 left over. So 3 groups of 7 10s are how many 10s? Let me ask it again. 3 groups of 7 10s. Ooh, you're so good. Are 21 10s. What's another name for 21 10s? You guys are so good. Okay, you know where it's going, right? It's going to look like this. All right, so here's what I want you to do. I'm going to ask you to talk to somebody who's near to you right now. The goal for a child is not this. The goal for a child is this, with an understanding of that. Okay? It would be embarrassing if we had to send these kids to middle school and say, boys and girls, don't forget your little baggie of chips because you're not going to be able to divide when you get there, right? That is not the goal. The goal is that they can do this, but they understand where it comes from. So take just a moment, turn and talk to someone around you, and decide what are the connections between what you see here and what you see here. Find some connections. What do you notice here and here?
Just that it's a, you kind of visualize the quantities, and as they, they're kind of organized similarly, but there's a visualization there.
Yeah, absolutely. I love that you use that word visualization, because that's one of the things I talked to teachers about just a few moments ago as well. How important it is for a child to be able to visualize what's going on in mathematics. Do we still have 525 heads of lettuce? Mm-hmm. We do. It's just organized differently, right? Some kids don't know that. Some kids think that when you're dividing, you're getting rid of something. You're not getting rid of anything. You're just building it in a different way. Where do you see this?
Each row.
Yeah, 3 groups of 175. We were just talking about the fact that the use of a manipulative in the classroom takes time, right? It does take time, and that's hard for some teachers, but it's so worth the time investment when you think about all of the learning that is taking place. So I want you to think about some things that you learned that we didn't even talk about. What would happen if this farmer had 527 heads of lettuce? What would happen?
Leftovers.
He would have had salad for dinner, right? Mm-hmm. Yeah, there would be a remainder. He'd have these 2 heads of lettuce left over, right? You know that, not because we did it, but because you can picture what would happen if I would have had those 2 more ones, right? What do you know about what this would look like on a place value mat? Can you picture how that might look? Just like that in reverse, right? We would start here and we would end where we started. So yes, it's an investment of time, but think about all the things that we learned. We learned its relationship to multiplication. We learned, oh my gosh, we learned to understand what division is, right? And what all those numbers mean. So, same mathematics that you learned, different focus. There is a focus. Your kids will eventually end up in the same place that you ended up in terms of efficiency with procedure, but they're not going to start there.
Have a better picture.
Yep, absolutely, better picture. All right, so just so you know where this is going, so you can see how this is really similar to how we think about it, right? Okay, there are questions that ask them to really focus on the procedure. Again, they just don't start there. There are also questions like this. Remember when I told you that that thing at the beginning of how Singapore kids are different than American kids, right? This is an example of a question like that. This is a division question, isn't it? But what do I know about a child who, well, what would the way that they solve this question, what would it tell me about what they know? If a child changes or solves this by saying 2,560 divided by 8, what do I know about them?
The practical applications of math in the world.
Good. They can connect what they know about division to repeated subtraction. What do I know about a child who on the margin of their page says 2,560 minus 8, minus 8, minus 8? What do you know about that child? It's going to take them a really long time, isn't it? Right? And they don't know. They haven't made the connection between what they know about repeated subtraction and division. They don't have as deep of an understanding of division. American kids can do that. We just haven't asked them to do that often enough. Right? They're also going to be asked questions like this. Same math, different focus. You cannot, this is one of the things I talked to the teachers about just moments ago. You can't teach a child to think. You can just consistently put them in situations where they're required to do so. And so this curriculum is certainly going to give kids some procedural skill. It's also going to consistently ask them to understand the mathematics deeply enough that they can think at a high level about it. All right, so myth number 1, same math. We're going to skip that one. Myth number 2, success in mathematics is primarily determined by innate ability. So you believe this if there has ever been a moment where you have said this in your home. Well, she's just going to have to wait till her mom comes home to help her with math homework, right? If you've ever thought or said something like that, maybe you think some people are born to be math people and some people are not. The truth is, a child's belief that they are capable of becoming a strong math student is much more important than the ability that they were born with. It's really crucial that your children believe that they're capable of being a mathematician. And that's a switch for many of us, because that was not necessarily true for us when we were growing up. When I was growing up, it's kind of like these people are going to be the mathematicians, and these people are the artists, right? Or something like that.
Hands on.
Yeah, there you go. Every child is capable of being a mathematician. If your child struggles with mathematics, I would encourage you to adopt one word into your vocabulary, and that's the word yet. So when they come home and they say, I don't get this, you say to them, you don't get this yet. So that children know they're capable with work. So we're going to look at how mathematics supports every child to be a mathematician. If you were to ask a teacher in Singapore to describe what they value in terms of math instruction, they would probably show you this pentagon. This is what they use to communicate. Here's what's really important. So what does this tell you? What does it tell you? What do they value? Problem solving. They say that problem solving is the heart of everything that they do. There's really only one reason that we teach mathematics, and that's to strengthen a child's ability to think. Mathematics is a vehicle for sharpening our brains. All right? All centered around problem solving. What else stands out to you? Did anybody notice that all of these are equal? Yeah? Anybody know what this fancy education word metacognition means? Metacognition is this idea, it's really only a word that we use mostly in education, and it means the ability to think, to talk about how you're thinking about something, to describe what's going on. Really important in terms of moving forward in mathematical understanding. What do you think about this one? The writers of Math in Focus say it is as important for a child to believe that they're capable, that is as important as memorizing their multiplication sets or learning how to do long division. It's really, really crucial, because if kids don't have this piece in place, if they don't think they can do this, then none of the rest of this matters. This afternoon I had teachers from every grade level here with me, and I asked the middle grades and the high school teachers, what do you really want kids to walk out of elementary school with in terms of mathematics? Guess what they said?
Good attitude.
Yep, a belief that they can do it. We want them to not hate it when they reach 6th grade. We want them to think that if they stick with it, they It's really, really, really crucial, and that takes us at home as well as teachers in the classroom. So let's look a little bit at about how Math and Focus does this for students. So this idea of metacognition, which we've already talked about, students are going to be asked questions where they really have to describe, how do you know that this is true? So for example, something like this, where it's not about, is this the answer? It's about, how do you know if that's the answer? I was with a group of 5th grade students today, and we answered a question that was similar to this. And so it was a fraction addition question. And they were given the question, and then they were given the answers that 3 make-believe students, really, out of the text gave. And so their job was not to say who was right or wrong, but what would they say to each of those students, right? So they'd say to one of them, well, you can't, when you're adding, fractions, you can't just add the numerator and add the denominator. You have to have like denominators, something like that. So one little boy said to the girl in the text whose answer was clearly too big, I called on him and I said, I can't remember his name, what would you say to our friend, Nora, who's one of the students? And he said, I'd say, Nora, you're off. I'm like, okay, that's a good starting point. So getting kids to engage in not just what is the answer, but understanding the mathematics behind it and communicating that. In the classroom, teachers are asking questions like this, are you sure? Even when a child's right, are you sure? How do you know you're sure? I don't know. Right? You mentioned visualization earlier. It's a really key part of this curriculum, a way that students are asked to develop a better attitude about mathematics is through the ability to picture it. So we're going to try a few. Nobody has a paper. Well, you have a piece of paper. So, okay, so.
Don't ask me to do anything.
Oh, we're going to try it. So you might just have to picture these, okay? Here's what I want you to do. I want you to decide what you think the answer to this is. And you can figure it out in any way that you want. And then turn and talk to the person beside you and decide. You did know that this was going to be an interactive session, didn't you? Once you think you know the answer, will you turn and talk to somebody around you and decide if you agree? So, before we talk about the answer, has anybody read the book Thinking Fast and Slow? Okay, put it on your reading list. So this is a book that is not written for education, but it's actually, I think about it every single time I think about this question, because it talks a little bit about how, not a little bit, a lot about how our brains work. And it says that in our brains, whether you're an adult or whether you're a child, we really have these 2 systems. We have a fast thinking system, right? And here's what the fast thinking system in your brain does. It looks at a question like this, and it says, pick out the numbers and do something with those numbers really quickly, okay? What's the problem with that? Sometimes that thing you do really quickly is not accurate, okay? So we also have this other system in our brain, which is a slow thinking system. And that as adults and as kids, we need to slow down enough to make sure that our answer is reasonable. It's a really normal thing to engage, for adults and kids, to first engage the fast thinking system. Right? Guaranteed somebody in this room did this, because I've never done this question with a group of kids or adults where there at least weren't a few people in the room, so be brave right now, this is you, who said this, 1/3 and 36. I know what 1/3 of 36 is. I hope the next question is harder than that. So it's 12 and 24. Okay, 1/3 of 36 is 12. The other number must be 24. Okay. Do you agree that the numbers are 12 and 24? Who can convince us that the answer cannot be 12 and 24? Somebody convince us.
Because 3 times 12 is not.
12 is not 1/3 of 24. 12 is half of 24. Why did many of us look at that and say 12 and 24? Why? It's easy. That's the fast thinking system in your brain that says, like, look at those numbers and do something really quickly. So one of the reasons we want kids to visualize is to slow them down enough to be able to say, wait a minute. Does that make sense? Okay, so here's what this, oops, we're going to draw it here. Here's what this looks like for a Math and Focus student. This is my larger number. What's my smaller number look like?
1/3.
1/3. Can you see it?
Mhm.
In your mind's eye, can you see it? So here's my smaller number. And what do we know about the larger number and the smaller number?
Added together they make 36.
I'm not looking for 3 equal parts. I'm looking for 4 equal parts. Do you know what a fourth of 36 is? You do, don't you? 36 divided by 4 is 9. What are my 2 numbers?
9 and 27.
9 and 27. Right? Doesn't that make that question seem very different when you slowed down for just a minute and said, wait a minute, what does this look like? Okay, we're going to try another one. Do you have it in you? You do. So again, you don't have paper pencil. So here's what I'm going to just challenge you to do. Just think about what this might look like. And think about what it might look like, and then we'll work on it together. Oh, there's nothing wrong with that. So before we solve this question with a picture, we're going to look at what it would look like if we were solving it with algebra. Okay? So we'll just all do this together. So if this is John's allowance, what's the first thing that John does?
Divides it by 4.
Why? Why?
1/4.
Yeah, because he spends 1/4 of it, right? So if this is what he starts with, then he spends 1/4 of whatever that amount is. What's the next thing that he does?
He takes 1/3 of that,
Ooh, he takes 1/3 of what?
the remainder.
Yeah, he takes 1/3 of what's left here. Okay? So I'm gonna say, I'm gonna shortcut this for us. He takes 1/3 of 3/4 x. All right? 1/3 of what was left here. And then what do we know? What's the last thing we know?
And that equals 18.
Yeah, he's left with 18. Okay, does this make anybody like want to stand up and walk out of the room? Right? Oh gosh, the hair on the back of your neck is standing up. It's okay. All right? I just want to show you how this comes to life, because this is how our teachers would have asked us to solve a question like this. Ultimately, our teachers would have wanted us to do this. But many of us as adults look at that and say, oh my gosh, that's craziness. Like, get me out of this room. Okay? Here's what the picture looks like. This is John's allowance. What's the first thing that he does? And what else? He buys a book with 1/4 of it. Okay, so there's something about 1/3, because the next thing that we know about John is that he spends 1/3 of the remainder. So here's the remainder, right? What would 1/3 of that be? Why 1 part? Yeah, there are 3 pieces left, so 1/3 of that must be. What do you know? What do you know at this moment right now that you didn't know earlier?
He spent half of his money.
Okay, you know that now, that he has spent half of his money. There's probably something else that you know now that some of us didn't think about in the beginning.
He spent $18.
Okay, ooh, that's a good thing to know too. You guys know a lot. Nobody's naming the thing I was thinking of, but those are all really good things. What do you know about the cost of these 2 things? Not what it is, but the relationship.
They're equal.
They're the same. Nobody looks at this question and says, oh yeah, the book and the stationery cost the same, right? But now we know that. And so you named a couple of other things. So we know that this is $18, right? And you know he spent half of his money. If these 2 units are equal to 18, what else is true? Okay, so I know that each one, you guys are going to think that the answer to every question in Math and Focus is 9. It just happens to be. It's not true, but it just happens to be for these 2 questions. What else do we know? Ooh, I know his book cost $9, and the stationery cost $9. I know he spent half. Kids only
Algebra is so much easier.
Kids only really care about one thing. What do they care about?
$36 allowance.
How much is John's allowance? Thank you very much. That's all they care about. If I was going to solve this question in this way, I could tell you ultimately what 1/4 of x was, but I wouldn't be able to answer all those other questions. He spent half of his money. that these two things are the same. You can see right there that his allowance was $36. If there's one math class that you really want your kids to be successful in, it's algebra. Now, there's a lot of research that says that algebra, success in algebra, is a really accurate indicator of how successful kids will be in terms of other classes beyond algebra. It's all about logic. In order for a child to be successful in algebra, we can't wait until they get to middle school and high school to start. We have to have them thinking algebraically long before we expose them to X's and Y's. All right? Okay. So, power of visualization. And then the last thing really quickly about how kids are supported to be successful is that this curriculum has really systematic lessons for students. So we're going to look at a first grade one. This is a first grade lesson where kids are learning about patterning and numbers. I'm not going to show you the whole lesson, but I'm going to show you some snippets of it so you can think about what this experience would look like in the classroom. So the first thing that kids are going to do, sorry I don't have my remote, these things are crazy, is to think about building patterns. Okay, they're going to have connecting cubes, they're going to be building different patterns, and they're going to be describing them. What does the pattern from 4 to 7 look like? What does the pattern from 9 to 6 look like? So you can see they're patterning up and down. Then they're thinking about putting some language behind that. What would it, so just incidentally, anytime you see a picture of a manipulative in Math and Focus, it doesn't mean that children are learning math by looking at that picture. It means they had those manipulatives in their hands. Right? So kids would be learning this by their teacher giving them connecting cubes and saying, show me 3. What does 1 more than 3 look like? Show me 5. What does 1 less than 5 look like? Questions like that. Okay? Building them, right? Then they're asked to answer some questions like this. So scaffolding is a fancy word in education for how we give support to students and then we pull that support away. Do you see that happening here? Yeah, they have support of a picture, it goes away, different numbers. So it means a child could go back to that support if they needed it, they could build it if they needed it, but we're going to see how do they do without. Okay, so those are the first 4 questions. Then later on they're asking questions like, or answering questions like this. It's the same lesson. What do you notice? Which one of those is hardest?
Maybe the one that started with 2
Ooh, do you think, anybody else think this is the hardest one? I'm going to say that's the easiest one. Why is that the
No,
easiest
not
one?
that one, I mean number 7.
Oh, this one. I agree with you. I think this one's the hardest. Why?
Because they don't know what to start with.
They have to pattern in both directions, don't they? They have to know what is 1 less than 7, what is 1 more than 9. Do you notice that not one single one of these questions looks exactly the same? So remember that thing that we talked about, what Singapore kids are really good at? That they're really good at taking what they know and applying it to something that looks unfamiliar? This is how we get kids to do that. It doesn't happen when you teach kids something and you ask them 20 questions that all look exactly the same. It's when you teach them something, you really build understanding, and then you ask them questions that ask them to think flexibly about what they know. Okay, so really systematic lessons. Myth number 3, I promise we're going to fly through these next couple. It's okay, so that blank is a place for you to insert your child's name. I'll use me. It's okay if Shelly isn't successful in math. He or she probably won't pursue a math-related career. Here's the truth. It's not okay. Not every career is a math-related career, but there really are no careers that don't require the ability to think and reason. If there are those jobs, you don't want your child to have them. Okay?
A thankless job.
A thankless job, right? This is something, and there's a lot of research that backs this up. This is something that has really changed in the U.S. over the last, even over the last decade, is that those jobs that are the jobs where you don't have to reason are going away. Why? Because people are building machines that can do those jobs. And if you can buy a machine to do a job or hire a human to do that same job, businesses are always going to go for the machine. It doesn't need vacation, doesn't take a coffee break, doesn't complain when it's too warm in the office or whatever. So it's not about that your child is going to grow up to be an engineer or a mathematician or a scientist. It's about that they leave school with the ability to reason that opens up a lot of doors for them. All right? So we want kids to apply their knowledge. Okay, math and focus. I'm not going to show you these examples all very quickly, or I'm going to go through them very quickly. So we've already seen examples of this, that kids are being asked consistently to apply what they know. This curriculum is going to ask them consistently to reason. We're going to look at a first grade example of this. So first or second grade, parents of first or second graders, have you heard your child come home talking about number bonds?
Yep.
Yeah, okay, so because they've experienced it. So number bond, there's nothing magical about the number bond. It's just a way to compose and decompose numbers. It's one of the visuals that's used in Math and Focus. So in the classroom during this lesson, this is the very first number bond lesson, kids they'd have 4 connecting cubes, and they'd be doing things like talking about what are all the different parts that make up a whole of 4. So some kids are going to say, oh, 3 and 1 make up 4, 2 and 2 make up 4, 4 and 0 make up 4. They're building that, and the number bond is just a way for them to keep track of their thinking. So in this chapter, first grade kids are having experiences like this. They're answering questions like this. If you have a whole of 6 and a part of 3, what's the other part? 3, you know that one. Okay, good. They're asking questions like this, or ask questions like this. They're also asked questions like this. It's all one question, by the way. What do you know about a 6-year-old who can answer that? Amazing, right? You guys are all answering it right now first. That's okay. What do you know about a 6-year-old who can do that?
Their comprehension of it is a lot more than the
It
internet.
is. They really understand this. They're also very systematic in their approach. Okay? Lots of 6-year-olds can do this. We just haven't often asked them to do something like this. Take what you know, apply it to something that looks different. If you have a whole of 6 and a part of 2, what must the star be? Okay? If you have a whole of 7 and a part of 1, what must the square be?
Take the 2 and add the 2.
Put it all together. I would argue that that's an algebra question for a 6-year-old.
Yeah.
It is, isn't it? Okay? Consistently putting kids in situations where they're required to think. Right? One of you, I think you mentioned perseverance. Oh no, did somebody mention perseverance earlier? Maybe that was with the teachers. I actually think it was with the teachers. This is one of the other things that the middle school teachers said they really want. They want kids that'll stick with it. It's an interesting thing in the U.S. that many kids give up really quickly when it comes to mathematics. And partially that's just the culture of what it looks like in the classroom, is that they give up because they don't think that they can do it. So it's really important for a child to have success in math so that they can do all these things. They learn how to stick with a task. They learn how to be systematic in their thinking and to reason and to apply knowledge to a different situation. Myth number 4, if they don't know the answer, or if they know the answer, they must understand the math. If they know the answer, they must understand the math. There is a big difference between understanding the math and being able to find the answer. We probably all could name an experience from our own education where we knew how to find the answer to something, but we didn't really understand the math behind it. So we're going to look at this example. 7 times 8. Do you know the answer? You do. How do you remember that answer? You memorized it, right? Right? Sometimes our teacher taught us a trick, like 56, like 5, 6, 7, 8. That's one that, people use. Did you know that little trick? Oh, okay. So you do now, right? A child who has memorized this fact has just memorized the fact. They don't necessarily know all the mathematics behind it. So the writers of this curriculum, before a child memorizes their facts, they want them to build understanding. This is actually what I worked with some 3rd graders on today. Can you picture what this would look like, right? What would this look like if you drew a picture?
8 rows of 7.
Ooh, 8 rows of 7, or what else? 7 rows of 8, okay, good way to picture it. It might look like 7 groups, and each of those groups has 8. Okay, so what does that tell me about what you know about 56? It tells me you know about multiplication, that it is groups of something, right? In Math and Focus, the first thing that we want kids to be able to do is to be able to visualize an understanding behind the facts. The first facts they learn in this curriculum are the 2s, the 5s, and the 10s. Why start there? Why start with the 2s, 5s, and 10s?
Simplification, it's just easy.
They're so easy. Like, there are kindergartners that know the 2s, 5s, and 10s because they can skip count by 2, by 5, and by 10, right? If I only know the 2s, 5s, and 10s, how can I figure out an answer for this?
Sorry.
Do it,
No.
do it. If I only know my 2s, 5s, and 10s,
5 times 7 is what?
okay, ooh, okay, so I know you know, so she's gonna start us off. I know that 5 times 8, I'm gonna do 5 times 8, okay? I know what 5 times 8 is. What else do I need to know to get to that?
What's 2 times 8?
Oh, awesome, you guys are so good. All right? If I know my 2s and my 5s, I also know my 7s. So some parents would say, so what? Like, that takes so long, right? Can't they just memorize it? They could, but a child who understands this has a strategy that they can apply to a question like this. How would I do this?
2 times 8.
What are 2 groups of 18? What are 10 groups of 18? Right? So it's more than knowing the answer, it's understanding the mathematics behind it. So there might be times this year when your child comes home with something and you think, oh my gosh, why don't they just teach them the answer, how to get the answer? That's a goal, but first we want to develop understanding. And it's important to remember that that understanding is not just about the question in the moment, but really kids generalizing some mathematics that they can extend to further, or to bigger questions. Right? It's so important. Last myth. My role as a homework helper has ended.
Yeah.
Do you think that you were hoping that this is true? It's not true. The truth is, it hasn't ended, it's changed. Okay, so I'm going to give you just quickly a couple strategies for how to support your student at home. The first one, oops, we're going to go back here. The first one is to think about what you do when your child is struggling with something at home. This is a picture of a very common thing that parents do when their child is struggling. And, and here's the move that we make sometimes. They say, hand me your pencil. Let me show you how to do this, right? I'm going to encourage you before you say to your child, hand me your pencil, that you start by asking them some questions.
What you know.
Exactly. So here's a great question. Did you use a manipulative or a visual in class today? Okay, get them to describe to you how they learned this, this content. What were they doing in class today? Can they describe that to you? Here's another one. How is this question? So let's say that a child gets to question number 4 on their homework and they get stuck. And ask them something like this. How is this question, number 4, how is it like the ones you were able to answer? How is it different? Right? So one of the things that's very common about a workbook assignment in Math in Focus, and we've seen some examples of this already, is that the question is going to change a little bit. They're going to vary the way they're asking a question. So if you can get your child to say how 2 questions are the same and how they're different, it will really unlock for them some ideas about how to deal with that difference. Okay? Last question, what might be a good way to begin? For many children, the most difficult part of solving a question is knowing where to start. And so just talking with them about where might we start with this? Why do you think that's a good idea? Can help them just trigger some response to that. So rather than, and I know it's so tricky, kids come home to do homework and they're hungry and tired and you're hungry and tired and you just want to have it over with. As much as you can, instead of immediately jumping into, let me do this for you, ask them some questions to help them move forward, okay? And last but not least, know your resource. So your child has a textbook that they use in class. If you think that you need to, it's worth asking a teacher to see that textbook. You could flip through, I mean, I've been showing you lots of screenshots of the textbook. You can flip through a lesson and really see from start to finish how the math was taught. And so that's helpful for a parent. If you have had a moment where you think, I don't know how to help them with this, taking a look at the textbook is really valuable. And then your most, your primary resource is this person. Not this person exactly. This is not a teacher. This is just some random teacher that I found on the internet. If this was a teacher in your school district, I would want my child to be in his class. I'm just going to say. However, so the very best resource that you have is your child's teacher. You guys have the same goals for whoever your child is. And so just know that if you are noticing something at home, so frustration or, wow, I think they need more time with the manipulative, or they always get stuck with this type of question, it's really worth having a conversation with your child's teacher. Please know that this curriculum is new to them as well. So as with any new curriculum, there are growing pains that everybody's trying to figure it out. So just keep that in mind, that they're learning, in some ways learning alongside your children in the classroom. Not the mathematics, but just using a new resource to teach that mathematics. Right? Okay, in the 4 minutes that we have remaining before group 2 comes in, what are the questions that you have?
I have struggled with helping my son struggle with estimation, especially at division, and I didn't see you cover that at all.
4th grade? Mm-hmm. So here's a really interesting, so I'm going to talk, I'll address that, but I'll also link it to something that's true for a lot of students, is that, and this is true at any time that a district might adopt a new curriculum, is that this curriculum expects that students, so this is a mastery-based curriculum, so that means when they teach something to children, they give them enough time to master that concept, and then when kids see that concept again, they're not revisiting it, they're building on it. So there are going to be times, and that's a perfect example, there are going to be times this year, especially if you have a child that's in one of the intermediate grades, so 3rd, 4th, or 5th grade, where kids are building on something, but they didn't have the precursor to that at a younger grade. So perfect example in 4th grade, that in the 2nd chapter, students are asked to estimate a quotient. So using what you know about multiplication, what do you think, is about the answer to whatever? Well, the problem is, and not a problem, it's just a reality, is that in 3rd grade, those same students didn't have the foundational piece for that. And so it's something that's just going to happen from time to time this year. It's one of the things I talk to teachers about today is transitioning back. How do you go back and reconstruct prior knowledge for a student where they don't have it? And that's a tricky one. It really is, because there is a multiplication and division chapter in 4th grade. It's the next chapter. So it's really saying in that 2nd chapter, can you estimate this? Now let's apply it to bigger numbers. So it's not, the challenge is that it's just a transition, And the good news is, though, that two pieces of good news. The teachers have resources for that. There's a whole bank of resources that are available electronically and also in print, where a teacher can trace a concept back across the grades so that they can go back and reconstruct this prior knowledge with their students. That's not the estimation question I was expecting you to answer. There's a really interesting, probably the most highly controversial aspect of this curriculum. There is an estimation strategy they teach called front-end estimation. Anybody have experience with that? Did you want to say like that is craziness?
It's the format.
I think we all called the teacher.
You know what, here's what's really interesting about it is it's introduced, so just so you know, those of you that haven't had fun of front-end estimation yet, it starts in 3rd grade, it goes all the way through 5th grade. And it is, this is what it looks like. If I am estimating or rounding, I'm going to say rounding the number 321, front-end estimation says just use that leading digit. So 321 becomes 300. Okay, we're okay with that. But 397 also becomes 300, because you're just looking at the front end. So we know what the challenge is, right? It's really inaccurate. Here's the reason they teach it. They teach it because it is an estimation strategy. It is most applicable if I'm dealing with really large numbers. But the primary reason for teaching that is when kids get to 5th grade, there's this whole piece of front end, actually there's a little bit of this from 4th grade as well, front end estimation with adjustment, where you are saying, okay, round to that front end number. Now, how would you adjust your answer to make it more accurate? That's not about estimation for a 5th grader. It's about logic. can you think through? It's a really difficult concept to teach and to understand when you're brand new to this curriculum. So just hold on to that one loosely. If your child is not a master of front-end estimation this year, it's okay. They can still rule the world. Yeah. Any other questions? That was a good one.
So this curriculum is being introduced here and through 1 through 4, 1 through 5?
1 through 5.
Uh-huh.
It is, I mean, obviously in Singapore they do math all the way through. And by the way, in Singapore they do not call this Singapore math. Do you know what they call it? Math, just math, that's right. We're only Americans are the crazy people that call it Singapore math. Obviously in Singapore it goes all the way through. In the US it has only been introduced kindergarten through 8th grade. Haines is using it kindergarten through 5th grade. Other questions? I think it's really awesome though that middle school and high school teachers were here today to kind of talk about what does this look like, because they're going to be getting these kids coming to their classrooms. All right, I'm going to hang around for the next group and to answer any other questions that you had. You guys were delightful. Go home.